What's up, everybody? Welcome to the 16th lecture of Trig. Today I thought we'd go over the Exam 3 study guide, especially since, for those who haven't been keeping up with the syllabus, Exam 3 is next Thursday. Newsflash, Exam 3 next Thursday, don't forget. I will not accept late exams without an excuse 24 hours in advance. Let's get that out of the way. But anyhow, having said that, start on these problems. Let's start with that first one. For the first problem, you might look at this and be tempted to say, well, let's just go ahead and jump to the identities for tangent. Let's go ahead and write, or apply rather, the identity tan of u minus v is equal to tan of u minus the tan of v, all divided by 1 plus tan u tan v. Yeah, that seems like a reasonable leap, right? Let's just go ahead and apply that right away. There's a catch though. Tangent, all of these tangents are undefined at pi over 2, so we can't use it. We can't put in tangent of pi over 2. That gives us nothing. So we can't use this identity. So what do we do instead? Well, instead, we want to go back to what tangent actually is, what it breaks out to be. Breaks up to be, I should say. Tangent of pi over 2 minus u can be rewritten as the sine of pi over 2 minus u divided by the cosine of pi over 2 minus u. And if we don't recognize these two things to have an identity attached to them, which it does, which they do, I should say, we might then, if we don't recognize the identities, we might want to just go ahead and jump to the formulas, which is a good idea. That's what you're being tested on anyhow, right? So the identities in question would be the sine of u minus v is equal to the sine of u times the cosine of v minus the cosine of u times the sine of v. And the identity for cosine will be cosine of u minus v is equal to cosine of u times the cosine of v plus the sine of u, the sine of v. Well, applying that to this, we're going to find then that this comes out to be 1 times cosine of u over 1 times the sine of u. Which means all of this is going to come out to be just a cotangent of u. And that's all there really is to it. Since we can't apply the identity for tangent of u plus v, or I mean of u minus v, since we can't apply that, we want to break up tangent into sine and cosine and use those identities. And this is going to be a common trick, a common method that we're going to want to use throughout most of these problems. Cool, let's look at the next one. So for this next problem, we just want to apply one of the double angle formulas, right? In this particular case, we want to apply the formula that 2 the sine of u times the cosine of u is equal to the sine of 2u. That's all we want to do. We just want to apply that formula. All right, well, 15 degrees is equal to u, so 2 times the sine of 15 degrees times the cosine of 15 degrees is going to be equal to the sine of 2 times 15 degrees, which is really just going to be 30 degrees. Well, the sine of 30 degrees, this is 1/2. All right, 1/2. And that's it. That's all there is to it. Now, having said that, a question you should ask yourself with problems as we go through these is, how could I change this? How could I change this problem? Ask you the same problem, but with a little twist to it. Well, one thing I could do here is I could give you something that looks like this. Okay, so when I say I could give you something that looks like this, what do I mean? Well, I mean, I could, instead of giving you 2 times the sine of 15, cosine of 15, I could have given you 1/2. And in that case, you would have over here the sine of 30 degrees, all of that times 1/4. So let's look at a problem like that. Let's look at a problem like what I mean. I could give you, for example, something that looks like right? Well, if I did, your first instinct should be to say, this looks very similar to one of our forms, but I'm missing a 2. So, if I multiply by a 2 and I divide by a 2, that's the same thing as multiplying by 1, then I can force that 2 to be in there and have this constant that kind of just floats around. So let's look at what I mean. What I mean is, we could say 2/2 times 1/16 times the sine of 30 degrees times the cosine of 30 degrees. Well, that 2 over 2, like I said, it's just multiplying by 1. It doesn't do anything. But because of it, let's swap. Well, because of it, we can now force a 2 to sit inside of here, and I'll show you what I'm talking about. To find it, let's swap the 2 in our numerator with this 1/16. Let's just move them through the parentheses. When we do that, we're going to get 1/2 times 1 over 16 times 2 times the sine of 30 degrees cosine of 30 degrees. Well, this 1/2 and this 1/16, they multiply together, and then it'll give us 1 over 32. So we'll have 1 over 32 times 2 times the sine of 30 degrees times the cosine of 30 degrees. Which will give us 1 over 32 times the sine of 60 degrees, which we can solve now. So this is one of the examples I mean about, like, asking yourself, looking at the study guide, how can I change these problems? Still ask the same thing, but add an extra layer of understanding to these problems. Cool. Let's look at the next problem. All right. So for this next problem, the hint that's provided kind of makes this pretty quick and easy, right? The hint tells us that the tangent of u over 2 is equal to sine of u divided by 1 plus the cosine of u, and all of that's going to be multiplied by 1 plus the cosine of u. So now we get to do everybody's favorite part of math, cancel things out. So you suck, and we're just left with the sine of u, which is equal to square root of 3 over 2. Okay, so we're solving for u. That means we can just apply the arc cosine to this. The arc sine. Actually, let's go about this a slightly different way. From here, we can just go back to the unit circle. And on the unit circle, we find that the sine of u equal to the square root of 3 over 2 has 2 solutions. One here, and the next one right about this, at the same spot straight across, which this is not, but my circle is kind of wonky anyhow. So the sine of u2 is equal to the square root of 3 over 2. But we know where both of those exist, don't we? Yeah. This exists at 2 pi over 3. And this exists at pi over 3. So we're done, right? Those are our two answers. Not quite. Because we can keep going through this circle over and over and over again. So we have to account for every 2 pi rotations. Yeah, I know that was really obnoxious. It's kind of awesome, right? So because of the fact that we have to account for every 2 pi rotation, we have to say that u is equal to pi over 3 plus 2n pi, or 2 pi over 3 plus 2n pi. There's still one more thing we have to do, though. We have to let the reader, whoever's looking at your problem, whoever's checking it, whatever, we have to let them know that n is an integer. And that's it. We're done. So let's look at the next problem. All right. So in this next example, what we first want to do is we want to find the hypotenuse, the length of the hypotenuse for this particular triangle. Well, we've been doing that since like day 1 of class. That's just going to be the square root of 3 squared plus 5 squared. So it's the square root of 34. Okay, that was quick. Found the hypotenuse of 34. I mean, the length of the hypotenuse. Now, we know as much as we're going to know about the triangle without doing some other work, right? So here, the first step that might be most useful to us is to write out all the double angle forms for cosine. So we know that cosine of 2 theta is equal to cosine squared of theta minus the sine squared of theta it's also equal to 2 cosine squared of theta minus 1. It's also equal to 1 minus 2 sine squared of theta. Well, why don't we go ahead and find what cosine and sine are, since clearly we're going to need them. Without knowing what theta is, we can still find sine and cosine. We know that cosine of theta is equal to the adjacent side, the length of the adjacent side divided by the hypotenuse. Well, the adjacent side in this case has a length of 5, and we've already found the hypotenuse. So cosine of theta is going to be 5 over the square root of 34. And sine theta, well, it's going to be the opposite. So it's going to be three divided by the square root of 34. So cosine squared of theta is going to be 25 divided by 34. And sine squared of theta is going to be 9 divided by 34. So using that first formula, we know that cosine squared of theta minus sine squared of theta is equal to 25 divided by 34 minus 9 divided by 34, which is going to be equal to 16 over 34, or 8 over 17. And that's it. Now, for an exam question, I could stick with almost this identical setup. Or I could give you the hypotenuse and not one of the lengths. Or I could give you the angle in the hypotenuse and tell you to find the rest of the values, the other sides, or I could give you the angle. I could do a bunch of different things, right? Like there's 1,000 different things I could do here. But yeah, in general, this is going to be the setup to this particular problem. So let's look at the next one. So, as an example of a question that I could ask on the exam that's not on the study guide, I could ask you to prove this identity. So how might we go about that? Well, I don't see a way forward using cosine u minus b, but I do see two different forms that I have identities, that formulas for, right? I know that cosine u times cosine v is equal to cosine u times cosine v is equal to 1/2 times cosine of u minus v plus cosine of u plus v. I also know that sine of u times the sine of v is equal to 1/2 times cosine u minus v minus cosine u plus v. So I know both of these identities, right? So let's put them through. Block those off first. So knowing that, we're just going to plug these identities into these two terms. First, we're going to have 1/2 times cosine of u minus v plus cosine of u plus v plus 1/2 cosine u minus v minus cosine u plus v well, we can distribute the 1/2s through, or we can just factor them all the way out. I think it'll be easier to factor them all the way out. So doing that, it's going to look like that. But when we do this, notice that means we can drop some of these parentheses. Drop that parenthesis. Drop that one. So what we have now are all these cosines being added and subtracted together. So let's group like cosines now. Well, the first two we see that are like would be these two. They're added together. So we're going to have 1/2 times 2 cosine u minus v. And the other two that we have in common are these two. Well, we're subtracting this and we're adding that. So they're going to cancel out. And we're just left with that single cosine u minus v. Well, when we distribute that 1/2 back through, that's going to cancel with the 2, and we're going to be left with just cosine of u minus v. So this is an example of a problem I might give on the exam. This would actually be a really good problem for me to give on the exam. Something like this, right? Cool. Let's move on. So for this next example, again, it's not on the study guide, but it's another good problem to know. Another good problem that I could throw on the exam. Now, looking at it, I don't know. Like, how do we show this? I don't know. But we could start by drawing out this triangle, or triangle because it doesn't exist, right? We've got a triangle that presumably is going to look something like this. Now, we claim that side B, let's call this side B, has a length of 25, that the interior angle has a degree of 85 degrees, or is of 85 degrees, I should say, and that the side opposite of it has a length of 15. Okay, well, if this is the case, then this angle here must be B, this one must be C, and this must be the length C down here, right? Well, if I'm going to prove that this doesn't exist, I don't know how I'm going to go about it, but I do know I can start at least to try and find B, right? Okay, I can find B using the law of sines. Let's do that. The law of sines would tell us that the sine of 85 degrees divided by 15 is equal to the sine of b divided by 25. Well, that means if we multiply both sides by 25, we'll get the sine of b, and we can solve for b from there. 25 times the sine of 85 divided by 15 is equal to the sine of b. But hey, wait a minute. This is going to be larger than 1. And sine of b can't be larger than 1. So this can't happen. This triangle can't happen because of that. Now, you probably recognize this example from the lectures because you're all good students and you all watch my lectures. You might be asking yourself here though, how can I change this problem so that how can I change this problem for the exam? Well, there's a couple different things I could do. I could ask straight out to prove that this can't happen. I could say, what do you have to change this to make this happen? That could be a thing. I could say a bunch of different versions of that, right? Like I could tell you, let C be this angle, let this C be this other angle. What does A have to be for this to happen, for this to work? So I could say, prove there exists no triangle such that blah, 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 blah. You go through, you do all this, and then it says, okay, now that you've done that, assuming C is equal to blah degrees, and little c is equal to whatever, what does A have to be for this triangle to exist? Well, we would hold this A, the degree, to be the same, and we would just apply the law of sines. We'd say, all right, well, like, this can't be 15, but because of all of this, if we hold the degree to be the same, what does it have to be? Does that make sense? I assume it does. If it doesn't, shoot me an email and I'll give you an example, a better written example of what I mean. I'm just trying to think on the fly how I might reword this on the exam. Because personally, I do like this problem. I think this is a very important problem for y'all to understand geometrically. Wink, wink, hint, hint, nod, nod. Yeah, let's look at another one. For this final example, what we want to do is we want to find the length of A, the length of B, and the area of the entire triangle. But before we do that, question of the week. This week's question of the week is describe in the worst way possible your least favorite movie. I'll be putting the discussion board up tonight. Those answers will be due by Saturday. By Saturday at midnight, I should say. Having said that, let's get back to this problem. So, to find the length of A and the length of B, we want to apply the law of sine. Now remember, what the law of sine tells us is that the length divided by the sine of the angle opposite of them are all equal. So in this case, since we know 110 degrees and we know the length opposite to it is 2, and we know what all the other angles are, we can set up relationships to find out what A and B are. So let's look at this. What I'm saying here is we've got the sine of 36 here, B divided by it, and A divided by the sine of 34. All right, so we can set up these relationships using the law of sine. The law of sines, plural, I guess. So, having said that, we just want to solve for A and B one at a time. Let's start off with B since it's the first one I got written up here. Looking at just B, we've got 2 divided by the sine of 110 is equal to B divided by the sine of 36. Multiplying both sides now by the sine of 36, we can solve for B. B is equal to the sine of 36 times 2 divided by the sine of 110. And we solve B. I don't know what that number comes out to be, and I'm not going to try to figure it out right here on the board. Just type it in your calculator. Having said that, we're going to use the same process to solve for A. Solving for A, we've got 2 divided by the sine of 110 is equal to A divided by the sine of 34. Multiplying both sides, find the sine of 34, and we get A is equal to the sine of 34 times the fraction 2 divided by the sine of 110. Again, I don't have the numbers written down. But yeah, so we found A and B. We still need to find the area. So to find the area, there are 3 different forms we might want to use. And they are all going to come out to be equivalent. To solve for the area, we're going to want to use 2b, the sine of 34 degrees, or 2a, the sine of 36 degrees, or AB, the sine of 110 degrees. All three of these will come out to be equivalent. Just throw them in, solve. So again, these problems, the study guide is not an exhaustive list of all the possible problems I could give you. Nor is it an exhaustive list of all the topics that could show up on the exam. For example, I could ask for you to prove whether or not certain triangles are possible. So I could give you a length, like 3 lengths and an angle, and say, can you make this triangle? Yes or no? To solve that, you'd use the law of sine. And we did that in an earlier lecture video. I don't remember which one right off the top of my head. I could ask you about the law of cosines. Or I could just throw old material in there, which kind of sneaks its way in anyhow. But don't think of this study guide, the point being here is don't think of this study guide as being an exhaustive list of all the problems I can give you. It's not. Don't treat it that way. Go through and look at the review section of the book, look through the problems, look through the notes. Again, exam 3 is next Thursday. October, whatever that is. It's not the 31st yet because I think that's Saturday. But yeah, a week from this Thursday, exam 3. Same time as usual. I'm going to be much more strict about makeup exams and about excuses. If you need to take the exam at a different time, I'm totally cool with that, but I needed a reason for it, right? And I need to be told 24 hours in advance. Anyone who misses the exam without a legitimate reason, like you got COVID or something, I will not allow you to take to make up the exam. So keep that in mind. You've been warned, right, guys? All right, having said that, have a good one. Enjoy your weekend, guys.